Hello. In this topic, we are going to see what is SAP HANA at a 50,000 feet level. And in the next topic, we are going to dig a little bit more deeper on the technical aspects of the HANA innovation. SAP HANA is a hybrid in-memory database that combines row-based, column-based, and object-based database technology. It is a flexible, data source agnostic appliance that enables customers to analyze large volumes of data with SAP and non-SAP systems. It does this in real time, and the best thing is it avoids the need to materialize transformations. These things allow customers to ask questions in real time and get immediate answers. This allows them to get deep insight and take decisions on a day-to-day basis. Since we are cutting down on the different copies of data and the silos of data, this leads to a lower TCO. We can handle unstructured data in a native way, and HANA has out-of-the-box features for text analysis and data mining. Let's take a look at what features and innovations HANA has. So in a snapshot, these are the different innovations which HANA comes with, namely in-memory storage, partitioning, compression, multi-core architecture, and massive parallel processing. Let's take a look at what these innovations are about. I think, in my opinion, the biggest innovation in this database in the hardware side of things is HANA stores everything on RAM. It stores and processes all the data on RAM. So naturally, it's much faster than processing the data on a conventional hard disk. Talking about numbers, the RAM is at least 1 million times faster than the hard disk. So that gives us a lot of proof that why HANA is very fast. And not only the hardware innovation, HANA also adds a lot of software innovations which makes it even more faster. But obviously these are mathematical numbers. In real life, it's not 1 million times faster, but it's quite fast. We can easily say we can see acceleration anywhere from between 10x to some cases 3,600 times. Compression has been with us for a while. This is a chapter in computer science, and softwares have been using this for a long time. But HANA does it very well in using this concept. It really reduces the data footprint by compressing the data. It stores column stores and row stores. So by reducing the footprint of the data, what we do is we reduce the amount of data which is processed and the amount of data which moves in between engines. So therefore the transactions are much faster. It also leads to a lower TCO because you are reducing the data footprint, and customer has to pay less for the licenses and also the hardware. HANA supports both row-based and column-based, but it advocates us to use column-based. Now, what is column-based database? If you see the memory has a sequential address pattern. So if you want to store data, you have to follow that address pattern. In a column-based database, the entries of the columns are stored in contiguous memory locations. So it might look like an Excel sheet with columns stacked, but these columns will be irregular because not all the columns have the same amount of entries. We will see this a little bit more in detail in the next topic. Why do we have to do this? Because column storage seems to be much faster for reading. It goes through the columns much faster and enabling us to do analytic transactions in a very high speed. It also enables us to process aggregates in a much faster way. These two are the main functions in an analytical query. If you see that one has to aggregate and one has to go through all the different rows and columns to get the required result which is requested by the application layer. Since HANA comes with inbuilt engines to handle logic and execution code, it's much better if you push the application logic, data-intensive logic, from the application layer into the database layer. Normally we keep the application logic and the database logic at the application layer. So we want to be able to push that down to the database because HANA can handle it much faster and it can do it much more efficiently. Naturally, this allows the application layer to do its job, which is orchestration and triggering the processing within the database. This frees up the application layer and gives a much better user experience. Because of hardware innovation, today we have servers up to 64 cores. So one server, one node has 64 cores or more. Today they are capable of building such servers. Naturally, we want to be able to use this computing power. The concept is pretty simple. Is what we want to do is we want to be able to partition the data. You can partition with columns or rows, or you can also look at partitioning your whole data footprint as tables and move them into different nodes. Together they give a massive parallel processing. The capability of partitioning and then running a query parallelly is the concept which HANA uses at a hardware level and also as a software level. So all these innovations of HANA makes it super fast, and in the next topic we'll dig a little bit more deeper in the innovations and get more details on the same.